motion. Are you ready? So let's start. What is force? Force is an interaction between objects. In this video, for the example, there is interaction happening between the person's feet and the ball. Force is a motion that is either a push or a pull. And then here, we're gonna talk about what impact can forces have on objects. There are 6 impacts that can force have on objects. The first is force can make object move. You can see the figure below. It is proven that force can make it move. The girl that hit the baseball is as a force. And then when she gives the ball a force, the baseball obviously will be moved. And the second, the force can make an object speed up. The figure below shows that when the girl applies a force in the form of blowing from her mouth quickly and strongly, then the paper propeller toy that she is holding will speed up and quickly. And the third, force can make an object move slow down. This is because the force that given is slow too. The figure below proven that force can make it slow down. And next, the fourth, force can make objects stop. The GIF below shows when the ball is rolling and then there is someone stopping the ball. The fifth is force causes it to change direction. The figure below shows the basketball has the down direction to the floor. And then when someone followed the ball to floor, the ball changed direction from down direction to up direction. And the last impact is force can cause it to change shape. In GIF below, in archery tools, force can change the shape of an object through a process called elastic deformation. Elastic deformation occurs when an object changes shape due to the application of a force. But the object can return to its original shape after the force is released. In archery equipment, there are several components that can experience elastic deformation, such as the bow steering and the bow itself. Let's see the GIF below. This is still illustration how the way mass can make an impact to the object. When there is someone push the object, like in this GIF is such as a block, the mass of the block and the mass of his body will be calculated and can determine how far the block will be pushed. Of course, the block will be moved, but we still don't know the exactly distance. So that is called in here as an acceleration. We will discuss this in more depth later about force, mass, and acceleration. And now, we will get to know who the figures are related to the subject of force and motion. Who was Isaac Newton? A renowned physicist and mathematician from England who discovered in 1687 the correlation between force and motion. Today, these 3 laws of motion are instrumental in describing the movement of any object in the universe. Newton's first law of motion. Newton's first law states an object at rest will stay at rest unless acted on by an unbalanced force. An object in motion will stay in motion at the same speed and in the same direction unless acted on by an unbalanced force. Because objects in motion stay in motion and objects at rest stay at rest, so there are figures and GIFs below. The first figure shows that a stationary object with no outside force will not move. The second is GIF shows that with no outside forces, a moving object will not stop. And then Newton's second law of motion. Newton's second law states that the acceleration of an object by a force is inversely proportional to the mass of the object and directly proportional to the force. The formula of Newton's second law is force is equals mass times acceleration.
Example, Newton's second law. Little force equals to small distance. More force equals to more distance. In order to get more acceleration, you need to apply higher force. Newton's third law of motion states for every action, there is an equal but opposite reaction. An example of Newton's third law is a rocket launch. When a rocket is launched, the hot gas emits from the combustion. An emission causes a reaction force to arise in the rocket, namely a force that lifts and accelerates the rocket. This incident is an illustration of Newton's third law. Now, look at these three questions here. We hope you guys as a student after watching this video can answer all of these questions. The first is, name instance where Newton's first law of motion comes into play. The second, provide example of when Newton's second law of motion is applied. The third, can you think of scenarios where Newton's third law of motion is relevant? Momentum, the measure of an object's resistance to changes in its state of motion due to the application of a force. Momentum equals to mass in motion. Momentum equals to mass times velocity. Example of momentum. There are three cars with different speeds and the same mass. The conclusion is that the higher the speed, the greater the momentum. Conservation of momentum, a scientific principle that states that the total momentum of a system or group of objects remains constant if no external force acts upon it. This principle applies to objects in motion. It is closely related to Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. M1v1 plus M2v2 minus M1 plus M2 times v. Conservation of momentum in one direction. When two objects interact in a single direction, the total momentum of the two objects before the interaction is equal to the total momentum after the interaction. Conservation of momentum in two directions. If two objects interact in two perpendicular directions, the total momentum of the two objects before the interaction is the same as the total momentum after the interaction in both directions.
An example of conservation momentum is when someone shoots and plays tennis. Gun and bullet system. Before firing the gun and bullet are the rest, so the total momentum of the system is zero. The gun is fired. The bullet comes out of the gun and gains conservation of system momentum. Then the gun will recoil. According to the law of conservation of momentum, the total momentum of the gun and bullet will be the zero after the gun is fired. Suppose m is the mass of the bull and v is the velocity while firing the gun. M is the mass of the gun and v is its velocity with which it recoils. So the total momentum of the gun and bullet after the gun part is m. And the example of conservation momentum play tennis is a homemade cannon is constructed to deliver an impulse to a tennis ball and accelerate it forward. The cannon experiences an equal and opposite impulse which accelerates it backwards. The momentum change of the tennis ball is equal to an opposite of the momentum change of the cannon. Next material is about impulse. Impulse is a concept in physics that describes the change in momentum of an object when a force is applied to it for a certain amount of time. In simple terms, it's like a force or kick that changes how fast an object is moving or in what direction it's moving. The impulse experienced by an object is directly related to the force applied to it and the time over which that force is applied. If you push a heavy book with strong force for a short period of time, it will experience a smaller impulse compared to pushing it with the same force for a longer time. When a force is applied to an object, it will result in a change of momentum. This change may involve a shift in velocity, such as an increase or decrease in speed, or a change in direction. For the formula of the impulse itself, you can see from the screen. This is example of impulse. When you want to apply force to a stationary ball by kicking it, there is an interval between swinging your foot and hitting the ball. This force is called an impulse. Inertia is the tendency of an object to resist change in its motion. It's like an object's natural stubbornness to stay still if it's at rest or to keep moving at a constant speed and direction if it's already in motion. The more massive an object is, the greater its inertia, meaning it's harder to get it to start moving, stop moving, or change its speed or direction. Meanwhile, acceleration, on the other hand, is a measure of how fast an object motion is changing. It can be a speed up or positive acceleration, a slowdown or negative acceleration, or a change in direction or changing where it's going. When you apply a force to an object, you're causing it to accelerate, which means you're changing its speed or direction. The stronger the force, the greater the acceleration. In simple terms, inertia is an object resistant to changing its motion, and acceleration is how fast that motion changes when you apply force to it. This is example of inertia. The first gift shows a hamster spinning, and the question from this material is what happens if the hamster stops spinning or moving, while the second gift shows a giraffe wearing a seat belt. Here the meaning of the gift explains why we need to wear a seat belt when driving a car. In the example of acceleration itself, it can be seen that the car is moving slowly at a constant speed. If a car initially moves very slowly, then gradually increases its speed until it reaches a higher speed, then the car is accelerating. This means that the speed of the car changes from slowly to faster, and this is what is called acceleration. Acceleration can occur in the form of either an increase in speed or positive, or a slowdown or negative, depending on the direction of the change in speed. Next material is about contact force and non-contact force are two basic types of force that exist in the physical world. First is contact force. Contact force is a force that occurs when two objects are physically in contact with each other. This force is a result of the direct interaction between the object through touch. Examples of contact force include pushing a book on a table, pulling a rope, friction between your shoes and the floor. And the second is non-contact force. Non-contact force, on the other hand, is a force that can affect an object without any physical contact. This force acts at a distance, meaning they can influence an object, even if there is no direct touching. Examples of non-contact force include gravity, which pulls objects towards the center of the earth without physical contact, magnetic force, where magnets can attract or repel other magnets from a distance, and the last is electric force, such as the attraction or repulsion between charged particles without direct contact. In the simple terms, contact force occurs when objects touch each other, while non-contact force can affect objects from a distance without any physical contact.